بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 7. We are in model 11, the last model in this year, sampling and statistics. Today we have the last lesson 5. This is the last lesson in this year. Assess visual overlap. In this lesson, we want to learn how to make inferences about two populations and will justify their conclusion using a description of the amount of visual overlap between sample distributions. The first idea in this lesson, interpret visual overlap. Interpret visual overlap. This is the first idea. Listen, please.
Interpret visual overlap. Teaching notes. You have learned how to make inferences about two populations by comparing the centers and variations of the sample distributions. You can also make inferences about how likely it is that the means of the populations are similar or different. A local veterinarian, Dr. Gibson, weighed a random sample of male and female adult dogs. The results are shown in the double box plot. Dr. Gibson wants to know how likely it is that the mean weights of female and male adult dogs are different. To do so, Dr. Gibson can informally assess the degree of visual overlap between the two distributions. The visual overlap shows the distance between the two means of the distributions, as seen in the shaded section of the double dot plot.
So what the meaning of the visual overlap means? The distance between the two means. As you see here in the first sample, the mean will be here, and the second sample, the mean will be here. The distance between them, this is the meaning of the visual overlap. To informal assess the degree of visual overlap, express the difference in the means as a multiple of the measures of variability. In other words, analyze the ratio. This formula, difference in means divided by mean absolute deviation. This is to analyze the interpret visual overlap, to analyze the experiment here. So what I do, the first step, find the measures of center and variability. Both distributions are symmetric. So find the means and mean absolute deviation. The first step, find the means for the females. This is the mean. As you see here, we have 2 dots times 60 plus 2 dots times 61, plus here we have 5 times 62, plus here we have 2 times 36 plus 2 times 64. Divide by the number of the dots will be 13, so the answer will be 62. And the same idea, you can find the mean in the males. You will be find here 65. So in the formula, we want to find the difference between the mean. So the mean weights for males and females differ by about 65 minus 62. 65 minus 62 will be 3 pounds. Then the next step, find each mean absolute deviation, MAD, by finding the mean distance from each data value to the mean. So we can find the MAD, the sum divided by the amount will be 0.92, and here the males, the same idea, will be 1.08. And here we have 0.92. Use the estimate about 1. And here we have 1.08. Use the estimate also about 1. So, to the nearest whole pound, the variability mean absolute deviation of each distribution is 1 bound. 1 bound. So this means the average distance is each dog's weight in the sample is from the mean is 1 bound. So the distribution have similar variability but different means. The second step, compare the difference between the measures of center of the variability. To compare the difference in means, the mean absolute deviation, find the ratio. Find the ratio. So this ratio important to compare the difference in the mean. So difference in means divided by mean absolute deviation. The difference in the mean will be 3 and mean absolute deviation will be 1. 3 divided by 1 will be 1. So the means are separated by 3. The third step, analyze the ratio. When the variability is small, such as 1 bound, the data are less spread out and more consistent. So Dr. Jacobson can have a higher confidence in making an inference that is likely the means are different. Because the sample means are different and the variability is low. So the ratio difference in means divided by mean absolute deviation takes both of this into account. Look to this table. The greater the ratio, the more likely it is that the means of the population are different. In this lesson, you will use the following combinations to informally assess how likely it is that the means of the populations are similar or different based on this ratio. This table is very important, sample distributions, and here we have the formula, separation between the samples, and here means of the population. And if the ratio less than 2, means should be less noticeable, means more likely to be the same. So I will repeat. When we have the ratio less than 2 means should be less noticeable, means more likely to be the same. And when we have greater than 2, the ratio will be greater than 2, should be more noticeable, means more likely to be different. So the ratio in the signature is 3, and 3 greater than 2 means the separation between the symbols for males and females is noticeable. The mean weights of male and females dog are likely to be different because greater than 2. For example, measure variability between population. The double dot plot shows the daily high temperatures of 2 cities from 13 randomly chosen days in July. The table gives the mean and the mean absolute deviation of each city. As you see here, we have daily high temperature using the degree Fahrenheit. The first mean, as you see here, the first mean will be 82, and the second mean will be 84. And the first mean absolute deviation will be 1.4, the second mean absolute deviation will be 1.4. And now, how many measures of variation separate the means of the samples? Make an inference as to whether or not the average high temperature in July is likely to be different for each city. So what we do to compare? The first step, find the number of measures of variability that separate the means of the samples. We have here the two means. Find the difference, 84 minus 82, divide by the mean absolute deviation. So will be 2 divided by 1.4 will be about 1.43. 1.43. So the means are separated by about 1.43 measures of variability. The second step, make an inference. Using the convention, provide earlier a ratio that is less than 2 indicates the means of the population are likely to be the same. Because why? Because the ratio 1.43 less than 2 means we have likely to be the same. Likely that have average high temperature in July is the same of each city. The second example,
Measure variability between populations. Teaching notes. All-in Airways and Etana Express are competing airlines. The double dot plot shows the results of random samples of flight times, in hours, from each airline. The table gives the mean and mean absolute deviation for the flight times for each airline. How many measures of variability separate the means of the samples? Then make an inference that compares the means of the populations.
As you see, we have the table here. Here we have the first mean, the second mean, and here we have the mean absolute deviation. So at the first, find the ratio. 5 minus 3 divided by 0.2. 5 minus 3 will be 2. 2 divided by 0.2 will be 2.22. So the means of the samples are separated by about 2.22 measures of variability. Then, when the ratio greater than 2, means it is likely that the means of the two populations are different because greater than 2. If less than 2 means the same. If greater than 2 means different. So this is our lesson today, and this is the last lesson in this year. See you, inshallah, in the next year. Thank you for your listening. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh.